Again, I've introduced Debbie a little bit, but just a little bit more. Debbie, it's the Blood on Capitol Hill. She worked with Senator Bob Kerrey. She has played a major role in organizing the thinking of agricultural offsets in pending climate change legislation. And she has written about that for think tanks, and now coordinating a certain amount of the agricultural sector's interest in the topic. And I think she's going to talk about that today.
Thanks, Tim. Thanks again for inviting me. As Tim knows, this is a subject near and dear to my heart. When I'm not working on biochar, I'm working with the agricultural sector, particularly right now on domestic legislation, that they have a great interest in making sure that they are treated fairly, if you will, and I'll talk about that a little bit today. These are the four things I want to talk about. I can skip the first one. I think we've talked enough about global climate change and agriculture. I'll talk about cap and trade and where I think agriculture fits in, and how cap and trade, I think, can be a transitional strategy to other things we can do in the future, including changing the Farm Bill, and how, in fact, we provide money to the agricultural sector. Talk very, very briefly about the policy landscape and why there's some huge windows of opportunity right now in terms of climate change. And then talk a little bit about the ag policies and things to think about. Again, how offsets within cap and trade can be transitional, and how we can use cap and trade to hopefully transform our agricultural policies. So climate change. This is why we're worried. Scientists say if we are, in fact, going to stabilize the climate in the time frame that we need to do it, we can't take any emissions reductions measures or technologies off the table. There's a lot of opposition to some of the policies and proposals for agriculture to participate in offsets, mostly coming from the environmental sector. It amazes me that there is this pushback, because agriculture has a valuable and important role to play in climate change mitigation, and why we would take that off the table, I find a little amazing. My premise is that we don't have the luxury of taking agricultural mitigation technologies or methodologies or activities off the table, and we need to incentivize agriculture's role. One of the things I have learned from working with farmers is they are very, very smart people, and if you give them the right signals that involve something green, they will do it. They don't respond as well to regulation. I like to talk about the Eugenia effect. I used to have a very nice woman who worked for me at USDA, and if she was not involved in decision making and I gave her a task, she would spend 10 hours trying to get out of a 1-hour task. But if I involved her in decision making and she understood what she was doing and why she was doing it, she would throw herself at it. I've seen the same thing happen in agriculture. If you don't involve the farmers and the producers in what they're doing and decisions that are handed down to them, they will work very hard around those decisions. They'll look for every legal or regulatory loophole they can find, especially if it makes farming harder for them. They are farming to produce food. They're not farming to produce cleaner water, even though they can. And they're not farming to produce cleaner air, even though they can. We have to give them the right signals and incentives, and I think we can do that through cap and trade. I have 3 definitions I want to talk about in cap and trade very, very briefly to set the stage for why, again, agriculture can participate. In a cap and trade, you set a cap, and the cap on the amount of emissions that can come from any one country or globally in the case of the international negotiations that we're engaged in. And that cap is established by policy. Hopefully it's based on science. It may or may not be in our country. Theoretically, the cap will reduce every year so that you slow, stop, and reverse your emissions over time. And it applies to only the largest emitters who are identified by the policy. Even though we talk about economy-wide cap and trade, it's really not going to apply to everybody, especially in the beginning. It will be the largest emitters who we can go after and know that we can get emissions reductions from. Economy-wide cap and trade is, in fact, a new economy. And in that economy, there will be a new form of legal tender called allowances. And an allowance is a ticket that says you can emit 1 ton or 1 unit of greenhouse gases. And anyone who falls under the cap, who is a regulated sector under the cap, will get a certain amount of allowances, and they can only emit up to that amount. of allowances that they hold in their hand. And this legal tender can be traded or sold on greenhouse gas or carbon markets. My third and final definition is about offsets. And this one is particularly important because what an offset represents is an emission reduction. Before offsets will be given in any policy that I've ever seen debated or written, you have to create a verified emission reduction to get that little form of legal tender that represents an emission reduction. And what you do is you can sell that to somebody who needs it. Offsets are given only to non-capped entities. If you are within the cap sector, you cannot generate offsets. You have allowances, but you can buy offsets as a member of the cap sector. And again, they can be traded and sold, and in a properly functioning greenhouse gas or carbon market, offsets and allowances are fully fungible. There's been a lot of discussion about, well, if we give offsets to agriculture, they won't have the same value as allowances. I'm not sure how the market would function in a properly functioning market where you have, in fact, verified and confirmed the offset before it was allowed or given to someone or traded or sold. It will be fully fungible. And then the most important point is that offsets are a transitional policy. If we are still utilizing offsets in 50 or 60 years, then we have done something wrong because we haven't created the technologies we need to create to really reduce our emissions reductions. Offsets are transitional. They help keep the costs of the cap and trade system down in those early years. And that's why they're most important in those early years. And that's why it's relevant for agriculture, and I'll get to that in a little while. As I indicated, cap and trade does, in fact, create a new economy. The Congressional Budget Office did these figures. Lots of entities have done analyses of what a cap and trade will be worth and what it will create in terms of market flows. CBO estimates in the first 20 years of a market, we're looking at $50 billion to $300 billion a year in terms of what's going to be traded. Over 20 years, they're talking $300 billion to $6 trillion. Now, this has captured the attention of every member of Congress, even though for a few years they didn't all grok it. Now they do, and now they're saying, oh, if this is a new economy, then maybe we won't do cap and trade. Maybe you actually have to pass all that revenue through us so that we can authorize it and then appropriate, because that's what Congress does. So that fight is happening right now in Congress. Why offsets for agriculture? Why should agriculture participate in a cap and trade market and be awarded offsets or be eligible to create offsets? And I'll go through the thinking on this, or at least my thinking on this. In the cap and trade program, the whole point is you go after economies of scale or efficiencies of scale. You go after the biggest emitters, and you cap their emissions, and you get them to reduce their emissions. So those are the largest ones. We think about power plants, but there's other large emitters that we will go after in a cap and trade. Smaller diffuse non-point sources are not efficient targets. If you think about agriculture, for instance, trying to regulate 2 million plus farms for greenhouse gas emissions is difficult. Farms are managed ecosystems, right? Trying to regulate a managed ecosystem for greenhouse gases would be difficult at best. So the thinking is we will not cap agriculture. We will allow them to create emissions reductions in the form of offsets. So that's why agriculture comes to this place where they're working right now to be recognized and included in cap and trade policies. I'll talk just a little bit about agriculture as a source and a sink. I think everybody is probably familiar with this, so I'll run through this very quickly. But agriculture does, in fact, create greenhouse gas emissions. EPA, USDA have figures that run anywhere from 6 to 8% in the United States come from agricultural sources. Most of this comes from the non-CO2 gases, methane and nitrous oxide. So in terms of creating offsets, ag can do two things. It can enhance terrestrial or biological sinks in soils and plants to create offsets, or it can reduce those non-CO2 gases, methane and nitrous oxide. Sources of nitrous oxide, soils, fertilizers, land application of manure are the largest sources. Methane, again, a lot of it comes from livestock and enteric fermentation. Manure handling practices can create a lot of methane. Rice cultivation even though we really only farm rice in 7 states in the United States, it is a source of greenhouse gases in the form of methane. So mitigation opportunities. Precision agriculture can actually help to reduce inputs, such as fertilizer inputs, and thus reduce the nitrous oxide emissions from soil. So if you're increasing what you're applying, you can reduce, or if you're reducing what you're applying, you can reduce nitrous oxide emissions, you can reduce nitrogen leaching and runoff. Changes in rice cultivars or changes in your irrigation practices, so you break that anaerobic cycle in rice cultivation, can reduce greenhouse gases. I think there's a lot of work underway and has been for a long time on changing rice cultivars to reduce methane emissions. And then changes in both feed for livestock and in manure handling practices can reduce CH4 and N2O. And then in terms of enhancing the soil carbon sink, I think Ratan and others have handled this. One of the things we didn't spend a lot of time talking about was rangeland management, but I'm interested in this because there's such a large land mass in our country in particular in rangeland. It poses, I think, a great opportunity for a soil sink, and I know some places where biochar is actually being land applied on rangeland, and we're seeing some great impact. So that's a potential area for the future. Agricultural offsets, I mentioned this briefly. Offsets in a cap-and-trade system are, in fact, a form of cost containment. If you enact a greenhouse gas mandatory reduction policy today, we don't, for the most part, have the technologies to get those emissions reductions tomorrow. Businesses who are capped and who have to comply with that policy need to make changes in their capital investments and their capital infrastructure, in their long-term investment decisions. They need to change their technologies. That doesn't happen overnight. So the role of offsets is to provide market liquidity, to provide some of those emissions reductions so that we can begin to reduce our emissions while we come up with those other energy technologies that eventually, hopefully, will save us from this problem. Soil sinks and agricultural reductions in particular are very interesting because it turns out they're actually good policy. A lot of the things that are inherent with soil carbon sequestration, like enhanced air and water quality, are good public policy. So if we utilize cap and trade to enhance the activities that sequester carbon and that reduce greenhouse gas emissions, we get multiple benefits. They are actually a form of charismatic carbon credits, as I like to tell people. I tell the farmers, when you go up and talk to members of Congress, you tell them, we have charismatic carbon credits. We don't just reduce carbon from coal-fired power plants, right? We improve the living environment for society. We have a lot to offer. I have one member of Congress who now says, and it's not rocket science, it's soil science. This is a generic slide, and Jay Edmonds and Norm Rosenberg and others at DOE have been working on slides like this for many, many years, and they do analyses country by country of, okay, if we have a carbon reduction policy, how do we do it? This black line here represents business as usual. So if we do nothing to reduce our greenhouse gas emissions in this country or other countries, that's business as usual, right? Our greenhouse gas emissions just go through the roof until we've fried the planet, I think. If we're going to undertake a policy, we want to slow, stop, and then reverse our emissions so that they're drastically coming down. The question is, how do you get from here to here? What technologies do you have? As I've indicated, we've got to work on a lot of technologies to really get down here. But in the early years, soil carbon sequestration is often anticipated as one of those offsets because we can do it across the broad landscape of this country and others. It's not high tech. And there's a readily available land resource and farmers willing and available to do this. But again, it's transitional. But it helps us in these early years, if you look at this, it can really help us bring down this emissions curve. That's why it's important in the early years. It's important to have early in your cap and trade. I like this chart because it talks about different technologies, those that are readily available, or deployable, and those that are not, and those that can be relatively minor or major contributors to reducing our greenhouse gas concentrations. Soil carbon sequestration is up here again because we can do it. And we can do it across basically the landscape of the country. And there are other things, again, that agriculture can do, but this is one of the very important early ones. And you'll see the non-CO2 gases, but I think we need a lot more data and a lot more technologies there beyond the just manure management, which I think we have a good handle on with methane digesters, but beyond that we need a lot more information and technology. So in theory, ag can play a great role. It can help us keep the cost of a cap-and-trade system down. It can create emissions reductions in the early years of the policy when they're most needed, and it can provide income generation for farmers if, in fact, you give them credits within this new economy. Policy landscape, I have this one slide. In both houses of Congress, this year we are looking at climate change in the House for the first time really in forever, I think. Climate change is being seriously looked at and debated. I don't think we're going to have a bill out of either house this year. Probably not next year either because of the midterm elections, but there's a lot of progress being made. There's supposed to be a markup in House Energy and Commerce. The thing I'd like to point out here is that I have been working on this since 1997. I've been working on this particular issue. Last year in May...
Probably 18?
Yes. Thank you. But last year in May, the first time since I've been working on this, members of the agricultural sector actually came to the table to negotiate in support of cap and trade if, in fact, there was a good role for them. It's the first time ever. And they are now all at the table. This is major progress. They finally see, okay, this is going to happen with or without us. We need to be at the table to see what we can get from this policy and how we can participate. So that to me is major progress. Of course, Barack Obama has made it clear that climate change is one of the very important policies that he will undertake early. And USDA, for those of you who don't know the Jamie Whitten building on 14th and Independence in Washington, USDA not only has a secretary, Secretary Vilsack, who understands this issue and the potential role of agriculture, but in the last Farm Bill, a Ecosystem Services Markets Office was created to look at developing protocols and methodologies for agriculture to participate in ecosystem markets. And they were given the orders by Congress to look first and foremost at carbon markets. They have populated that office. They're now working on this, and we're engaging with the agricultural sector. And the important thing is that USDA and the sector are talking and having, I think, a very valid discussion about this. And, I didn't mean to skip what's happening internationally. Again, I've been participating in the international negotiations since 1997. There was an agricultural workshop held in Bonn as part of the negotiations in April for the first time since I've been participating. All parties were there. They were, for the most part, both developed and developing countries, very supportive of including agriculture in the post-2012 regime as both a mitigation and adaptation technology. So that's very exciting. This is, I'm getting into the wrap-up here, issues and concerns for the sector. Economic impacts of cap and trade. There are going to be winners and losers in agriculture. Not everyone's going to be able to participate in offsets markets. Even soil carbon sequestration doesn't work everywhere all the time. And there are going to be some farmers who are hit by increased production costs and energy costs and fuel costs who do not have income generation opportunities. This is one of the things they're trying to think about and weigh in their own minds. Protocols. I'm encouraged by USDA working with the sector to develop protocols. We can come up with wonderful, tremendously valid and accurate protocols for how they can participate in carbon markets. If they're too onerous and they're too burdensome, they will not participate. We will not get offsets generation. There will be no income generation opportunities. So it's important that they be part of the process. All of the legislation that has been considered, with the exception of an amendment in the Senate last year, would give jurisdiction over agriculture and forestry offsets to the EPA. I think that's disastrous from the point of view of the sector. They would really like to see USDA jurisdiction be retained, and fortunately it's already codified in law now. I think it's a matter of protecting that. Again, I think I said agricultural offsets are important early for both costs and because if, in fact, we do, for instance, take advantage of soil carbon sequestration, there is that saturation rate that will be met after time. Measurement, monitoring, and verification, there's a lot of debate about this. I think it's a balance between cost and accuracy. And USDA has actually tested some protocols that combine sampling and something like the Century model or the DayCent model that has been created by Colorado State University. So combining on-the-ground measures with models is probably the most economically efficient way to do this. And then the issue of protecting existing carbon stocks. Not only thinking about building carbon stocks, but protecting our existing carbon stocks is very important. And how do you account for that in a policy? Maybe we don't do it in cap and trade, but maybe it's something we think about for the future in terms of farm bill policy. Again, I talked a little bit about lack of data, particularly for the non-CO2 gases. We need both better data on this and better ways to measure, monitor, and verify it. And then in terms of some of the definitions, what we really want to avoid in cap and trade and offsets policy is perverse outcomes. We don't want to tell a farmer who's been engaged in a certain activity for a long time, such as no-till, that he can't participate in future carbon markets or get paid for it. But that brings into question issues like additionality and baselines. And I won't get into how I would resolve those problems, but I have some very strong thoughts on that. And then I think one of the biggest issues we have to tackle both domestically and internationally is, even though we're looking at project-level awards for offsets, I think we eventually have to get to the landscape level. We're never going to resolve this issue if we look at just certain places and enhancing soil carbon stocks or reversing land degradation in certain places. It has to be done at the landscape level. I think that will come eventually. We have to give this a lot of thought and consideration, and there are some people thinking about it and noodling on it. And in terms of permanence, I think we have to think about duration and just enhancing and increasing the residence time of carbon in these terrestrial sinks. It's not permanent. By its very nature, biological sinks are not permanent. We're trying to enhance the duration of carbon in those sinks. So my wrap-up slide, ag emissions reductions can be very important, but they're near-term, they're transitional, they're not forever, they're not a silver bullet, they're really just a Band-Aid that we have at our disposal. And I think we can use cap and trade to incentivize good policy and build on that in the future. But the time is right to do this now, domestically and internationally. And again, if we don't include ag from the start, I think it's a huge missed opportunity for both agriculture and society in terms of the types of impacts and ecosystem services we can get. And after cap and trade, I think we immediately start looking at the farm bill. Whatever we can't do within a cap and trade system, we do in the future through changing ag policies. And again, farmers are at the table. They understand this. They now see the signal and the potential. So I think the time is right. Thank you.
Stand up here. That was an amazing, big summary of a big topic in a short time. I'm going to just speak for 6 minutes or so, playing a little bit of devil's advocate, and then we'll have a discussion. Why don't you go ahead and sit there, and Jan Eric, you can come on up as well. We can turn the lights on. I'm not going to use a PowerPoint. I have a great deal of sympathy with a lot of what Debbie had to say, but for purposes of devil's advocacy and illuminating the issues, let me bring up some of the challenges that I see and concerns. One of the biggest issues is that right now we're talking about using this capacity for ag offsets not to reduce agricultural emissions, but actually reduce energy emissions. Because the energy people will be regulated, and they're the ones who will then pay the offset in the agricultural sector, meaning they will reduce less. So right now, this doesn't actually get us reductions in the agricultural sector if we're selling them to the energy sector. There's a possible way around that, which actually I think Debbie was one of the people who came up with, which is having this idea of a set-aside instead, so that the ag, basically what you're going to do is require that the non-ag sector reduce even 5% more and give those credits to the ag sector if it can demonstrate through these systems that it's actually reducing carbon. That would go beyond, or reducing emissions, that would go beyond just the reductions in the energy sector, and it has the political challenge of kind of increasing the burden on the non-ag sector, but has a lot of benefits. The additionality issue, this is the question of, are you paying for something you're not already getting? And the challenge is actually shown by David Castle's presentation. hadn't thought of it until toward the end of it, when basically he was saying, look, there's this additional carbon we think may be sequestered because of no-till, because of things farmers are already doing. Look at all the credits we have. Well, the farmers are already doing them. So they're not paying them for those credits is not going to get you anything that they're not already doing. And one thing we really can't afford to do is pay people for a lot of things that they're already doing, because there are a lot of good things being done, and we're not going to get there if we just don't have enough money to pay for all the things people are already doing as well as new things. Let me raise a couple of unusual things. In the leakage category, people are probably familiar with some of the activities we might pay for, such as taking agricultural land out of production and planting it in trees, could cause plowing up of land elsewhere and releasing the same amount or even more carbon. And Debbie's fully aware of that, and her papers talk about it. I'm going to talk about an interesting element that people don't focus on. To the extent that doesn't happen, so to the extent that we reduce our production of food and don't get more plowing up, one of the reasons that doesn't happen, one of the reasons you do not have leakage, is that people can't afford to buy as much food. So one of the critical elements that is of non-leakage is reduced consumption. Now, in the energy sector, we don't really care. If they reduce their energy consumption, that's fine. But in the agricultural sector, we care a lot. Because what that reduced consumption means is the poorest people in the world ultimately are reducing a lot of their consumption. And so leakage has a particular meaning in this context, which is that to the extent that we get a greenhouse gas benefit, it may be at the cost of increased hunger. Now, let me talk very briefly about the measurement issue. And I think this is ultimately a key challenge. One of the challenges, it's very hard to go out and measure actual changes in carbon, actual changes in nitrous oxide, etc. So almost inevitably you end up kind of assuming the benefits of certain practices. And there are a couple of challenges there. One is that we know how people implement practices has a huge impact on whether you get a reduction or how much of a reduction. Let me give you an example. I was actually talking to Tracy Blacker and asking him about something called nitrification inhibitors. These are chemicals that you add to nitrogen fertilizer to reduce their transformation into nitrate, which ends up limiting the amount of nitrous oxide that's released. And there's a lot of uncertainty how well they work or whatever, but they do seem to work. But one of the questions is that some farmers, knowing they have this quality, will apply fertilizer earlier or more or do other things that actually increase the amount of fertilizer even as they're protecting more of it from being transformed. And so you can have this offset behavior that means you don't get the actual reductions. Now this is true across the world. When we think about it, when I grade a paper, it's not just has some student written a paper, it's how good is the paper. And that's true of agricultural practices too. How farmers implement these things has a gigantic effect on how big an impact it has. So just rewarding the implementation of a practice doesn't necessarily get you there. And there has been essentially a consistent pattern of overestimating the benefits of agricultural management practices precisely because we define them broadly. And all of the subtleties that Tracy was talking about in nitrogen management come into play in this regard. And then the last concern about that is that above all, what we need is technological transformation. I don't think we know how to get from here to there. We do not simply know how to reduce agricultural emissions enough while doubling food production based on existing technology. So we have to be promoting innovation. Now, the good thing about performance-based criteria, if you can really measure performance, is that rewards and incentivizes those changes. But to the extent we're making assumptions about standard management practices and the reductions they get, that goes the other way. Because now we're rewarding things that we think we know. We tell them, if you do X, Y, or Z, that is the established practice, we will assume a reduction. That doesn't create any incentive to go beyond X, Y, or Z. And in fact, it may ossify the process. If you look at the history of agricultural conservation, the cookbook of the USDA today looks almost exactly the same as the cookbook of USDA in the 1930s. And it's because of this emphasis on standard management practices as opposed to innovation. And And I think everyone would agree with that. So measurement is then the key to the game. But that is really the logistical challenge, because we know how hard it is, we know how subtle it is, we know how important performance is. So just a thought, 3 alternatives to the cap and trade, the typical cap and trade system, not all of which get around our challenges. One is a possible system for measuring greenhouse gas emissions per unit of production. That changes the game a little bit, because now you're saying, it changes the nature of the baseline analysis. Now we're saying we want to just encourage you to be more efficient in your production. That still raises a lot of measurement questions, but given the time, I won't go into all the details, but I think that it raises it in different ways and may be more promising. A second possibility is for some things just pay them. You know, that was my impression of listening to Cheryl's presentation. You know, it's not, there are a lot of benefits to those soil reclamation practices. I don't think we'll be able to justify those benefits just on carbon gains. So the answer is just come up with the money and pay to make them happen. You need accountability systems to reward those that work well, and maybe you reward things on a project basis, not on an individual basis. And then the last thought again is technological innovation is the name of the game here. And some of that can be done through private incentives. Some of it has to be done through public research and implementation of that research. The old-fashioned stuff we don't look at that much anymore. We kind of think, well, let's create incentives for the private market. Private markets are really important in encouraging innovation, but so are public markets, public research, public investment dollars in infrastructure and all that support. And we shouldn't forget that. So that's my 6 minutes. Maybe I'm going to be. Let's have a little bit of discussion. We'll treat to lunch. Why don't we have questions, comments from the audience, and we can all have some discussion. And good. But I wanted to also, at some point, I wanted to call on Tim to also give his thoughts on where we should be going. So Tim.
Well, let me just add that at the moment a little bit with sort of positing the challenge with you, Tim, from this perspective, and to say that I think if we don't have measurement involved in this, we're not going to accomplish some of the things that you just brought forward. And to me, measurement is crucial. Because if we get caught in a practice payment, all the things you brought up, I think, are problematic in the long run. Not only are farmers innovators, if in fact there is incentive payment for production levels of carbon in the soil or rate reductions in nitrous oxide or whatever, the innovative levels on different soils of different regions and different climatic sections will start to move. And it's just like Christine Nichols, USDA in North Dakota with mycorrhizae and her farmers up there. And in one county where they started to plant 15 species of cover crop seed after they harvested their wheat, which normally that ground just sits during the winter, and this time it grows, and then they run cattle through that, and they have, with that stubble left, they end up collecting the snow because there's only 10 inches of rain or precipitation up there, and as that snow collects, it percolates there. We know the importance of ground cover for building the biology plus the biomass at the same time, and we need the moisture. In that one county, 500 farmers show up on those farms to learn what's going on because that soil's turning black, it's turning rich, it's building soil. The other thing about innovation, if we pay for measurement, there are farmers now, and this isn't happening at universities, that are creating innovations that are talking about building 8 inches of topsoil in 1 year. And these innovations are not going to come out of the classical PhD scientists who are stuck within the silos of training. It's going to come out and be driven by someone who cares about profit and cares about building the resiliency so that they have that year after year. And science can show up and learn and assist and sometimes add to that practice. So I'm very concerned as well. And Debbie, I appreciate all the work that you've done over the time because I think we've got to be really careful about just paying for practice. Right now, USDA doesn't even count what some of the organic systems and the biological systems can bring. They don't even give credit for it when we can step it up 2 and 3 times than what the conventional practices are. So this is where if you step back and start to measure, so it sort of pushes the question about the measurement technologies, which Ratan and I'll begin to address. And there are some out there now that are starting to show some pretty good promise in hyperspectral and infrared or near infrared. that can start to come with pretty high associations to actual levels of carbon or actual levels of other ecosystem services, as well as, I think, which may be simple things like nitrogen mineralization is showing a very high correlation to carbon in the soil, faster than we can measure the carbon, because carbon usually takes a lot longer time. So we have to begin to incorporate this pretty rapidly, and I think from a policy standpoint, this is part of the incorporation that's going to have to come into play before we drop into the default mechanism. Let's pay for practices, let's get farmers involved. Now, by the same token, we may lose some time if we don't do a bridging. So, Debbie, I appreciated you bringing in a conversation of saying, in a way, how do we pay for what we know now? But there ought to be a sunlight clause in this thing so we can adapt and we can move. As the technology moves, we don't get caught, as you said, Tim, we're still dealing with some things from the 30s. And that, I think, is a danger in our policy questions, is to not solidify something in, but to allow the dynamism so that innovation will be incentivized.
I should make clear, we have convinced the sector they are not going to get paid for activities.
Great.
They are all out there pushing for measurements and measurement-based technologies for all of the practices, including soil carbon sequestration. The political problem we had to get over there was the CCX paying people for activities, but they are all perfectly clear, and all of the documents we are bringing to the Hill now include a desire to get paid for just shown reductions of greenhouse gas emissions or increase in sequestration. Because we are confident, we've talked to USDA, we've talked to a lot of soil scientists, we have the technologies to do that, as Bertan pointed out. We know the uncertainties of different measurement technologies. What we need is the methodologies and the protocols that different farmers can utilize in their different systems, because farming is so diverse. You know, farmers change their practices from year to year. They don't want to get into one practice that they can't change over time. So we need measurement systems that will adapt to what they're doing and bring enough certainty that they can make some money on the carbon markets. But so perhaps I should be clear that I think 5 years ago it was a very different outlook among the sector, but they're realistic now, and they've heard from members of Congress, you know, we're not just going to pay you for no-tilling.
I wanted to take up the point of technological change, because that's key. You were actually talking about change of management practices, at least as part of what you seem to be referring to as technological change. For me, technological change is a part of the toolkit. It's not the solution. I mean, we have to create a different mind frame, really, in my understanding, to make change. Behavioral change is required in addition to new technologies, and we shouldn't forget about that. You can't solve everything with science. You have to understand it's changing society's behavior. Organic farming can't do with technology. You have to understand the system.
Just a very quick thing. And Debbie has played a key role in focusing on measurement and certainty and all of the right tests. It is, however, a question of degree, and here's some of the challenges. So take an issue of no-till. We've talked about some of the measurement issues relating to the carbon in no-till. But there's other questions of does no-till increase nitrous oxide emissions? So the people at Colorado State have developed the model that is used to measure tillage practices. Also put out a paper that found that over the first 10 years, there are likely to be increases in nitrous oxide that cancel out the benefits of the carbon. So only if you were to do no-till more than 10 years. Wide uncertainties, however. Now, we're not going to go out and measure nitrous oxide. It's just too damn expensive and too hard. So that raises the question, how do you do that? Because if we're not measuring nitrous oxide, then that's a key factor of the tillage change. That's where the challenge comes in. So I think what it does mean is that by the time we meet all of the tests, and again, to Debbie's credit, the legislation I know she was involved in has all the right tests, it means we will limit to a limited category of activities or things we can measure the opportunities. And let's assume that gets it exactly right. There will also be other things that are more uncertain that we can't measure that we want to encourage. So that means we're going to have to find additional tools if nothing else, to kind of do more. Back.
I'd love to hear what your thoughts are on the most promising measurement techniques. So you mentioned a combination of measuring and the century model, but just more detail on what you're seeing in terms of either high-tech or soil sampling. Your thoughts?
Ratan mentioned a guy named Lucian Wojtowski, who's at Brookhaven National Labs, who is working with other scientists on some technologies you put on the back of a tractor, you run around your fields and kind of doing random sampling that have pretty good overlays with actual on-the-ground soil carbon sampling. And there's a group headed up by Chuck Rice at Kansas State University and some folks at University of Maryland who are now kind of testing those technologies against what I would call the gold standard, doing 120 soil carbon tests on any plot or piece of land. So those technologies are under development. I'm working to make sure that they are in fact accurate in different places, that they do in fact have an uncertainty measure, if you will, that we can test, that they're affordable for use on farms. But I think the one that USDA, Colorado State University, developed is probably one of the ones we'll see early on, and it combines taking soil samples across 5,000 points in the United States and feeding those soil samples up into two models, the century model and the dayset model, which both model carbon cycling and nitrogen cycling in the soil. So, and the beautiful thing about that is as you get more of those measures and feed them up into the model, you improve the robustness of the data in those actual models. So I think there's a lot out there that's very promising. There's even some handheld ones, but I think what we really need is the larger ones that we can, either put on a tractor or do satellite-based measurements, and those are all being developed.
Michael Albersteiner, Michael's a modeler. I think he tends to favor too much these modeling approaches, but he was talking about some progress here. Why don't you mention what you were saying last time?
We were running a project in Europe where we actually looked at the costs of the different monitoring systems.
Well, you come on up here.
And
you're a soft-spoken guy.
And what we found was that if you really strictly follow the IPCC rules for soil carbon assessment or soil carbon change assessment, you get to a cost of about $300 per ton of carbon, which is completely unrealistic. So what those guys, Pedro actually, some of those guys involved in it to come up on so they came up with a system, they call it area-framed randomized soil carbon sampling. And what they found was if you just do it for 1 hectare, it costs about 60 euros per ton of carbon change assessment. If you do it on 50 hectares, you get the cost down to about a euro per ton. And if you combine it with modeling, this is what in practice you will actually do. We run a 60 million euro project in Europe where we're just finding out how much that is, and we do it in total greenhouse gas assessment, and you get the costs down to the 1-digit percentage of what you would get in terms of greenhouse gas reduction compensation. So, if you do those kind of things, and as Debbie said, over time you actually get better. So what you would do is, at the beginning, you would, for the carbon or for the emission change assessment, you would go for a precautionary kind of assessment, where you basically just look at the system, where you would make sure that you don't overestimate what you claim by, let's say, 5%. So you put a safety buffer in there, and there the models become better over time, and you get actually more credits in that sense. And so I think overall, and also for avoiding deforestation and many other things you do in the biosphere, if you do it on clever enough, using models, be it statistical models or biophysical models, and if you do it on large scales, you have economies of scale, and economies of scope if you combine it with other observing systems, also water, for example, which you cleverly would do, then you get down the costs to basically very negligible amounts. And of course, if you plan for policies and if you want to advise farmers and so forth, you gain much more knowledge. So you actually create benefits. And so it's not only a cost item, it's actually monitoring is also a benefit item. I hope I convinced you on that.
I have a question regarding your nitrification inhibitors. How efficacious and efficient are these inhibitors? Because there's a room for improvement always.
Right.
And this would be an excellent project that would access to give to really modify the existing nitrification inhibitors. So what successful data you have?
Well, and anyone else who's even more, there are a few papers I've read. The most positive papers on results in reduced nitrous oxide are from CSU, and then I've seen some papers by Phil Robertson kind of questioning that. So it's an area where I don't really know the answer of how much it is. It is a lot of the estimates of the potential benefits from the IPCC are based on this, but I think they're in their early stages. So I would think that if there are going to be areas of progress, it's probably a tracing paper.
Let me just come in directly on this. This is an old technology. It's been around for decades, and it's usually too expensive.
What about tracing? Is it too expensive in the U.S.?
Well, the cost isn't that expensive in the U.S. for the production versus the price of fertilizer, but the problem becomes in terms of how it's used, and you're still dependent on the environment and a lot of other factors. So there's no doubt it's a nitrification inhibitor. It does inhibit the rate of nitrification. But like in Iowa, most of our nitrogen fertilizers apply in the fall. And the idea is that it'll help delay the conversion to nitrate to save it until the time the plant takes it up in the spring, which typically really, from a practical point of view, there's not much nitrogen taken until June. So if you're delaying the conversion from, let's say, November to December to March, but it still converts over in April and May and leaches out before the plant takes it up. I mean, it does have a transformation, but the way it's being utilized doesn't show in that effect. It actually made, the comments that we had the other day, it actually gives a security to putting it out. Now, it improves the odds, it does protect it to some degree, but it's not a permanent conversion. There's a time window, and there's conditions. We have very high pH soils in parts of Iowa that increases the rate of nitrification much more than what a nitrification inhibitor affects it. So it's the specific. It's a tool. It's like any other tool. But there's not one tool that fixes all problems. There's a use. There are conditions. The same with urease inhibitors and controlled release products. There's a lot of them, and we do a lot of testing on it. And there are some very specific circumstances that you have favorable odds. There are a lot of them you do not. If you can't predict the right amount of fertilizer to begin with, and then trying to protect it, percentage of it, from a business point of view, it doesn't make sense. From an environmental perspective, that's a different thing. If you have a certain niche, but where's your bigger improvement? So I think it does play a role, but a lot of times you have to understand the circumstances, the probabilities, and where it fits. And to me, it seems oversold at times, but it is definitely a tool.
And this is part of just the complexity that I see. Although I'm excited by the word Michael was describing, but this is kind of an example. If you want to know, has a practice or has something generated a benefit if you haven't measured it, now you have to know, when did the person apply the nitrogen? What kind of soils does the person have? Maybe what rainfall pattern? When you start getting into a lot of data that you would need to have even to make a rough estimate on that particular farm. So it's a challenge, and what we discover is that the reality intrudes, the complexity of reality intrudes. There's always this dichotomy between kind of the modelers and the kind of field people, to me, in kind of whether or not something is a good estimate of our potential benefit or not. And I don't know how fully resolved it, but I think that as we move forward, making progress in these areas is absolutely critical to solve the problem, because it's also true that we're not going to go out and measure every place. We need to have the principles we've got.
I might add just real quick, the trials we've had, last year we had a number of them that were favorable economically, say the fertilizer. In previous years, we had years where not a single one paid. It's that variable where we're targeting in our usage testing.
We'll have one more question, and then we'll go to lunch. But we're going to, from 2 to 3, we're going to have an open-ended discussion of all of these kinds of questions where we go.
This is for Debbie Reed. Thank you very much for that very interesting presentation. Do you have evidence on the efficacy of biochar in balancing out the severely acidic soil? That's a major problem in Asia.
Yeah, it's an interesting question. I talked about biochar not being one substance, but a spectrum of substance. It turns out how you produce the biochar, whether it's from gasification or slow pyrolysis or fast pyrolysis, as well as what the feedstock is, will determine what the pH is. And what we're finding, for instance, is that gasifiers create a much higher pH biochar. So whether it turns out that we're going to have little boutique biochars or biochars in niche markets, one of the things we want to do at IBI is to come up with a classification system that will help you determine what feedstock and what form of pyrolysis or gasification will create X product and where that product will work best in soils. Because not all chars are going to work in all soils.
Let me get one more home field advantage question in
Okay,
here.
sure. Go ahead.
Because I don't want to miss this opportunity. I'm curious about, we've talked a lot about technical potential. I'm curious about, and you can point me in the right direction, there's probably been some good work on this, but identifying some of the efforts to identify the real pool of offsets related, just for example, to soil enhancements. The IPCC talks about technical potential, and they drill down, they do talk about economic potential. So I know there are models out there, but there's a lot of complexities. I mean, as this discussion, Tim talks about these complexities and feedbacks. So I'm curious, it comes down, you said that there's farmers at the table, and there's a belief that there's just an econ benefit to doing this. They're going to come and they're going to pursue these practices. But there are the additionality questions that need to be figured out, because they're already pursuing these practices because of other policies, CRP, other policies. Is there somebody who has a good evaluation or making some progress on saying that this is really a worthwhile effort because of what is the pool of offsets that are really out there?
I think the problem with that, and a lot of the sector asks this all the time, the problem is going to be there's a technical potential for any of these technologies. Let's just pick soil carbon sequestration as your example. There's an economic potential, and there's a lot of models that show at $25 a ton, that's when farmers will change their practices to undertake no-till to get credits for carbon, right? But there's a lot inherent in that decision, if you will. I think it's going to be very different. I think part of the issue is that whatever the policy is will determine what the economic potential is, and then how much we're actually going to get. And so the devil will be in the details. The bill that's being debated right now in the House has no decisions in it. It simply says there will be offsets and may or may not be able to participate. EPA will decide in 3 years whether or not they can participate.
And I know from working with farmers that if the EPA is running this, they're not going to participate. A lot of them are going to say, if it's used USDA, it's more likely. And that's a very big impact.
It creates a huge hurdle. So they are unable right now to determine what the pluses and the minuses will be for them. Hopefully over time we'll have more analyses, we'll have more details, but I'm not sure when we'll have those details.
We're going to go to lunch, except I've never gone wrong at getting Dave Tillman the last word.
Well, hopefully you'll still be right on this one. This partial oxidation of carbon leads to lots of strange, often toxic compounds. And there are things like polyaromatic hydrocarbons left in at least many forms of biochar that I've read about. But what happens to those when they're applied to soil? What are the health impacts? I live in a city which has water contaminated by PAHs that have to be removed at massive expense to have the water be legally drinkable. So I'm wondering what kind of work has been done on the detailed chemistry of all of these complex partial combustion byproducts and what they do when they enter the environment.
There are some technologies for creating charcoal that do create a lot of the PAHs, for instance. If you create, the International Biochar Initiative would say, if you create a high-quality biochar, we advocate production systems that actually don't lead to the formation of those compounds and chemicals. And there are systems that don't do that. One of the things we're seeing now is people are out there saying, I have this thing I created and I'm selling it as biochar. There are going to be things sold as biochar that will be harmful to crops. I know one particular instance where somebody has a flash pyrolysis system that's creating a charcoal that has a lot of bio-oils, for instance, attached to it that are toxic to plants. That would not be biochar in our estimation. And one of the things we want to work on is a definition of biochar in these classification systems, because we want to avoid any of those impacts, as well as the creation, for instance, of dioxin. So it depends on how you create the biochar, and those production systems are not very complicated, but the how you do it is very important.
Well,
highly carcinogen. Correct. And it will react with
okay. Logistics-wise, I'm gonna cut lunch to 45 minutes because I'm a horrible man. We'll be back here at 1:15. We have a terrific panel to talk about particularly Indian experience and laws, and then after that, freewheeling discussion on where we go from here to close the conference. So thank you, Gar.
Well, it's just interesting how some little industrial